Hello, my name is Erlend Overby. I'm the chair of SC36, and I'm happy today to give you a presentation about how we collaborate with the IEEE LTSC to make standards work better for artificial intelligence, among other things. I'm also the founder of Hypatia Learning. We develop services that provide educational institutions the opportunity to take governance of all data produced by learners. And when you have all data about learners, you open up a new set of tools and opportunities to develop new innovative services, among using artificial intelligence, machine learning, so forth, to provide value for the teachers, the learners, the educators. And I think it's important to be aware that a standard is nothing more than a document describing something that a group of people has agreed to. And that could be anything. It could be a process, methodology, and within the IT world, it would be a data model, API, protocols, procedures, and so on. And what is different between a document that people are agreeing to with a document that is a standard is actually how it's governed and how it's being maintained, updated, approved, and so on. So different standardization organizations provide different type of governance and also different type of kind of business model for how these standards are made available. So within ISO and IEC, for example, membership is for free. Everyone can participate in developing the standards, but you have to pay for the standard to use it. And it costs usually around 100 plus US dollar for a standard. And today's talk or presentation is about how we in ISO and IEEE and other standardization committees can work to bring AI to the forefront of education innovation. And I think it's important to realize that our domain of knowledge is not AI and ML and machine learning. It's the domain of education, learning, training, skill making, and so on. So our role is then to provide our domain knowledge on education in general to the people who know how to do AI, ML standardization and development. And one role we also have is then to develop standards that supports the AI ML technologies in how to process educational data and content, and by that, and to ease that processing of data to be able to create services of higher quality. And we see that an opportunity for AI and ML is to develop new services for availability and to develop optimal learning path for individuals. And to be able to do that in a global scale across any learning resource, we need standards. We see now that there are companies developing availability within a closed ecosystem, but with standards, we can do the same within an open ecosystem for learning, education, and training. And to make that happen, there's a need to focus on the semantics and the standards of semantics. And in general, semantics is information about the meaning of something. And with standards, it was important to know that and understand that we have the tools to, on a global level, agree on what the meaning is, because it's defined in a global standard approved by our global community. So when you process data and you find some semantic markers from a global standardization organization like ISO, IEEE, and some others, your computer system could understand and know what the data is and how to process that and use that data for developing services. And when we have semantics embedded within the content in general, it's much more easier for ML systems to process the data because it knows the content about it. So you don't need to have huge corpus of data to reason what it's about if we, through standards, explicitly can tell you what the data is about. It kind of narrows down the scope of the processing, and you could process data with a higher relevance and higher accuracy, and then provide better value for the people using the systems. So with good semantics, it would be easier then to process the data for machine learning, and it would also be easier to create value with artificial intelligence. And in my committee, SC36, we have developed such a framework for describing metadata and semantics that actually solves and provide the tools for how to describe the meaning of content in a standardized way. And that's the standard of ISO IEC 19788-1, which is a framework for metadata for learning resources. And when you're talking about metadata, Phil Barker and Stuart Sutton has developed some principles that I think is important that we understand and try to comply to in the work we're doing when developing standards for metadata. And that should be entity-centric. It should be based on the model of semantic metadata, like in RDF, RDFS. And it should be syntax independence. It should follow the one-to-one rule from Dublin Core. That means one entity describes only one or one-to-one entity relationship. So one record doesn't describe more than one entity, and you don't have the situation where one entity describes two records. And it should support interoperability and the reuse of existing properties. I think that's very important. The reuse of existing properties. So if something is already defined and described, there's no point in describing that again in another standard for a different context, because we can reuse data. And it should support semantic local extensions. And should not have defined constraints like mandatory, must, should, shall, and so on. There should be no composite attributes like an XML structure or JSON structure as the value. It should be controlled value spaces. And that means that we should, again, describe the value spaces, the enumerations, the classifications, and the concept schemes as we describe the information itself in RDF, using RDF schemas. And finally, referencing any appropriate value space defined by others. So we should reuse to the greatest extent, and we should only define elements that are core to what we are trying to achieve. So those are the principles we should follow when looking into metadata and how to describe semantics. And I'm trying to exemplify this. I would like to give you a use case where the goal is to find an optimal resource for our learner. To be able to do that, we need to look into several different domain of metadata and semantic descriptions. We have the curriculum. We have a vast amount of learning resources, learning tools, and means you can use to train and explore and experience. And you have the information about the learner's past performances, the strength, the weaknesses, and their potential. We have the learner's need and preferences for how they would like to have content received, to be able to process it in a useful way. And then we have part of the learner competence, and also that means what the learner have been doing in the past. And then we have the learner or the educator's planned learning outcome and the learning activity. So we have information from a lot of different resources that are some are manually created metadata, and some are derived from processing of data of the learner activities. Like in our system, where you have all the data from a learner, you can then process this data to be able to enrich such a model. We need to kind of combine all these different aspects of metadata into one and see what are needed. We need to look into what are the curriculum goals, what are the teacher's expected outcome of this learning activity, what are the teacher's expected use of the learning resource, What are the preferences of the learner? What are the learner's performances from the past? And all the available learning resources available out there, which one are best fit to meet the learner's expectations? And then from such a system, we can then dynamically provide the teacher with a list of 3 or 4 resources that we think, or the system think, could be the best for the learner to reach the planned learning outcome of the teacher in this activity. So to make that happen, we could envisage that we have a unified set of metadata be described in the same fashion, and then you can process this metadata with the same tools, with the same goals, with the same expectations, with the same kind of AI machines and engines. And then by using AI and ML technologies, you can then identify the optimal resource for the learner and either present that to the learner itself or give the teacher the opportunity to choose and select what the teacher then thinks from his professional background what's best fitted for the learner. And to make this happen, we need to combine standards then from different organizations describing different concepts of this kind of information elements we are needed. For example, we have how do we describe a learning resource? That's work taking place in IEEE at the moment. It's also the work we've been doing in SC36 for some years. Learning performance, we might get something from how do we express qualification frameworks. And the learner competences, we might get data from XAPI and learning analytics. And curriculums, we might find that from curriculum databases and different ways of describing curriculum documents. And input from the teacher on the link to the curriculum and the learning outcome for this event, and expectation for how the resource is supposed to be used in the context of the education activity. And then the system will then automatically embed all this data and provide a sample to this one, to the educator or the learner. And that's it's actually an example of how we'd like to see different metadata being combined and supporting the principles that we are reusing where something already exists. So regardless of which kind of organization who have developed the metadata, we should be able to reuse it to achieve the goal we are searching for. And to go further, we can look into kind of the digital learning twin, where we have a virtual representation of the learner's digital learning activities and the planned learning in the virtual space. And we can use that to improve the learning experience of the learner. And it could provide a better way of simulating the different learning and collaboration scenarios to achieve the optimal learning outcome or the best learning outcome, or what best for the digital for the learner based on simulations of the digital learning twin. I think to make collaboration between these standardization organizations to happen and be fruitful, we should agree on some fundamental principles. For example, how do we express the semantics and metadata, and which type of metadata and which type of semantics that are described will then be managed by the group with the best competencies of doing that. And I also see that we, in the near future, we will have work looking into small data versus big data. How do we can transport algorithms across systems? And specific to AI and ML, we should establish principles within education and learning and training technologies for how do we do ethics, how do we do governance, how do we do explainability, how do we do trust, transparency, and usability, and all the other kind of soft aspects of AI and ML. So saying that, I would just say thank you. And we are now open for some questions.